Okay, I think we've got most people have joined us now, so we'll get things going. So again, thank you for joining us for this session today. So this is going to be part of our DR101 series, which is basically a bit of a high-level, more educational series, hopefully trying to teach you all of the things about DR that you might know, might not know, and hopefully have now going to get the chance to ask if we don't cover it. So just to get things going here, we've got two of us presenting today. So the wonderful Harry Smith is with me. He is one of the senior technology evangelists at Zerto. And you have myself as well. So I'm Keith Taylor. I'm actually the marketing content guru. So I'm normally tucked away behind the scenes on these things, but today you've got me thrust into the limelight. And as you can see just briefly there, this is going to be what we're looking at in this webinar, just covering a few brief subjects about why you need DR, what actually is the cost of downtime, and how can we measure that, what are the different technologies that are available to you, and in particular why automation and orchestration within those technologies and solutions is important to consider. Looking at the total cost of ownership for DR as well, trying to give you a little bit of assistance actually with planning and how you can build out your own DR plans. And then finally looking at the future of DR and where that perhaps is going to head in the next couple of years as well. And so first and foremost, we'll look at why you actually need DR in the first place. So the first point here is, as we can see, no one is immune to downtime. It is something that affects everyone. Modern businesses simply cannot afford to lose data. And there really isn't a single industry that can say that they're not reliant upon their IT systems in one way or another. And as of course we become more and more reliant upon those IT systems to enable the business operations and the provision of services, the need to protect that information becomes ever more critical as well. Now on this graph here we can see, or this chart, just a breakdown, and this was actually just taken from a small sample size in an Eponymon Institute survey. But it'll give you an idea, just as I say, from this small sample of how many industries have been impacted. And the breakdown of cost figures there as well is actually the financial impact on a per industry basis. So we can see that financial services right at the top of the list have perhaps the highest exposure, or cost exposure for downtime, whereas industries such as media and the public sector right down at the bottom are not, shall we say, less susceptible to downtime, but potentially have a less of a cost impact should they incur any disruption as well. Now, it is more likely than you think it's going to happen. Oh, sorry, Harry?
I'm so sorry to interrupt. I just wanted to remind everybody online too, if you do have questions, please put them into the questions panel and we'll try to get to everything we can.
Okay, thanks for that, Harry. So yeah, as I say, it is more likely than you think it is going to be. Unlike perhaps the picture that we showed on the intro slide there, it's not actually going to be these sort of apocalyptic natural disasters that really most people need to be concerned about. The chart here shows straight away we can see UPS or power failures, human errors, and cybercrime are all far more likely to actually cause a disruption to your business. We've seen this quite a bit recently. In fact, two major examples that fall into these categories are going to be the WannaCry ransomware incident, which we'll talk about a little bit more just after this as well, but that affected over 300,000 computers actually in over 150 countries, so it had a massive widespread impact. And of course the other one more recently was the British Airways outage, which although I think BA themselves are still trying to decide a little bit about exactly what has happened there, it seems to be that the root cause of that has been a power failure, potentially caused by human error. So you can even have a little bit of a mix of some of these categories as well, which can lead to an unplanned outage. We mentioned ransomware there. This has been a massive growing threat in the last few years, but it really has started to spike in the last year or two in particular. So we can see from 2015 to 2016, you had 167 times increase in the number of ransomware attacks that were detected just in that 12-month period. And this is obviously before the WannaCry incident as well, which, as I say, affected another 300,000 computers. And these are hugely disruptive for a number of industries. And again, WannaCry, we saw infections across the NHS here in the UK, our public health service. There were 61 individual trusts that were actually impacted by that. At Renault in France, actually their manufacturing plants had to halt production there at several sites. the Russian Interior Ministry, so even public sector organizations and those that you think might have perhaps a higher security and tolerance to this than others. In Spain, we had telecoms and gas companies affected by it, critical infrastructure there as well. And over in the States, FedEx, their delivery services were impacted too. So it really can be, as we say, anyone, anything, and at any time that can actually cause downtime. So if we move on to actually looking at measuring downtime, how do we quantify this, and how do we work out perhaps the cost of potentially what the downtime is going to be? First of all, it's important to look at these two terms, RPO and RTO, which you'll see come up very, very frequently throughout disaster recovery terminology. Just briefly to sum them up, RPO, your recovery point objective, is essentially the last point in time that you can recover your IT systems and applications to. So it's how much data you're going to lose measured in time between the moment an incident strikes, as I say, whatever point you can recover that data back to. Your recovery time objective is the other side of that line, so it's how quickly you can actually get your application services back up and running. And there are different factors that influence both of these figures. Your recovery point is largely going to be influenced by the type of replication technology that you're using. So something like backups are probably going to be taken once a day and are going to give you maybe a 24-hour RPO. Perhaps snapshots, if you're using those, maybe you're taking them once every 4 hours. So again, that's going to be your RPO, 4 hours potentially. Continuous data protection, because that's a constant replication, however, is going to give you a much, much lower RPO. You can measure in seconds, but you're still going to have a brief window, 5 to 10 seconds maybe there, where you're going to lose data. But obviously the cost of that is minimalized. And in terms of actually recovering after the fact as well, again, if you're looking at having a manual restore, that is going to be a very, very lengthy process. It could be hours, it could be days. If you can introduce a certain level of automation and orchestration into that recovery process, you can really start to reduce that down to just a matter of minutes to really try and minimize any impact that any disaster or disruption, cyber attack, whatever it may be, might have for you. In terms of looking at the cost of that downtime as well, now these figures here are basically sort of estimates calculated on a company with a turnover of over $100 million. But you can see even for just an hour, the cost of downtime is going to be very large. On the left, those three figures are for the RPO, so the cost of the lost data. And then you're looking at the additional cost of lost operating time on the right-hand side with the RTO figures as well. Okay, so there's a lot of factors that can affect both of these figures. There are some things as well that really are difficult to quantify within these, in particular stuff like reputational damage. If you look at the legal implications, again, actually just coming back to this British Airways incident, a huge amount of their cost is actually going to be through reimbursing passengers for the additional costs of their journeys due to cancelled flights and things like that. And that's not something that most businesses would normally look into quantifying when they're looking at costing out downtime. However, in the case of BA, that was such a huge incident. They were down for, I think, 3 days in total, or certainly having severe problems for that length of time. And the cost of downtime for that single incident is actually estimated to be over £100 million, $130 million. So it's going to have a colossal impact for the business there, as obviously we're still seeing coming up in the news. And if you want to take a look at this for yourself, you can go onto the Zerto website. We do have a downtime calculator that's available there for you. So you can pop in a few figures that are going to be more specific to your own individual business, and will give you a bit of an idea about what perhaps the cost of an hour or more of downtime is going to be for you individually. Of course, one of the main things that you need to be aware of, and the only real way that you can actually know what downtime is going to cost you and what the length of downtime is going to be through DR testing. If you can't actually test your DR plan and your DR solution, spin up the recovery, it's going to be very, very difficult for you to actually know how long it's going to take. It can purely be down to guesswork. And of course, the less practice that you have in actually going through your recovery processes, the more options you, or the more chances you introduce for errors to come in there as well. And it's something that historically a lot of businesses haven't done very often, or even at all in some cases. It can be a very, very time-consuming, very, very manual task. That really is as a result of, should we say, legacy technologies. But with the more modern solutions you can obtain for DR nowadays, DR testing should be able to be conducted at any time of day, during working hours, really in a matter of minutes and at the click of a few buttons. It shouldn't be a really complex and long-winded process, and should certainly be a feature that you should be able to utilize to assure not only yourselves, but also external agencies as well. And beyond being simple best practice, disaster recovery testing is a requirement for a lot of regulatory compliance in numerous industries, be it financial services, healthcare, public sector. In Europe and EMEA here now we have the GDPR regulations being introduced as well, which puts a burden onto many industries to ensure that they have suitable data protection or disaster recovery in place, and that they can prove the competency of that solution as well. So as I say, that's something that really is a key thing to look for when you are either seeking out a solution, designing a new strategy, or just embracing the world of disaster recovery for the first time. And just before we move on to the next section, this is one of my favorite quotes. If you've not read any of my articles, blogs, any of the other pieces that I produced for Zerto in the past here, I'm very much a fan of best practice, of doing things the right way the first time round. It really has a big impact down the line and can save you an awful lot of time, an awful lot of hassle, and an awful lot of cost in future. And as I say, this quote here I think sums it up really nicely, and hopefully you'll be able to take away some of what we're giving you in this session today when you're actually implementing your own disaster recovery solutions. And with that, we're going to move on to comparing replication technologies, and Harry is going to take you through that.
Thank you so much, Keith. And we did have a couple of questions come in. I answered some. One of them I'll address real quick before we move forward, and it was around what are typical constraints or limiting factors when testing a solution against a production environment or production running. And we won't dive too deep into that today, but constraints are always understanding what you can and can't include in your test, and understanding what that means for the success of your test as well, and documenting that. So again, we won't get into details, but we can follow up later after the webinar if you need more information. All right, if at any time the slides lag behind, let me know and make sure my audio is up to speed. But let's jump into comparing replication technologies and what that means for your business, and just to hopefully give you some understanding of what is out there compared to what you currently have, and help you make the right choices for different workloads within your organization. But we do have quite a few we'll talk about: array-based, replicating entire LUNs; agent-based, meaning installing an agent inside an operating system; hypervisor-based; synchronous, and asynchronous, and asynchronous. So I have those coming up on slides, so I don't want to speak too much to them yet. But before we jump into replication and disaster recovery, let's just level set and help everybody get on the same page as to why backup is not disaster recovery, because that's often the first stage of disaster recovery is I'm already backing up. It works great. There's nothing wrong with it. And yes, there is an absolute need for backup, but it isn't DR, and there are a lot of reasons why. Some of them Keith has already touched on, but we'll go through that as well in a couple of areas. But think about the RPO RTO, the service levels. If you're backing up once a night, that's great for certain applications and it's okay, but when does the majority of your work get done? Is it during the day? Is it 9 to 5? Are you a 24/7 business? How much business are you losing because you only back up once a night? How long is your backup window? How long does it take to actually recover from a backup tape or backup disk? All of those factors in your service levels, and really define those numbers, RPOs and RTO levels, to what your business needs and not what your backup technology does. So keep that in mind as you adjust this when you're thinking about disaster recovery. Automated recovery. How do you automatically recover? There are a lot of disaster recovery solutions that have built-in orchestration and automation that will help you spin up virtual machines and rebuild things if it needs to be done, reassign IP addresses. That's something that's extremely challenging to do when you're talking about backup and recovery from a backup solution. You can do them in certain areas, but definitely factor in there not only how much human intervention you need and the expertise you need behind that when a disaster strikes, but how much added time that takes to figure into your total RTO and before you're completely recovered from a disaster. And then in the disaster scenario where you actually fail over to another site, if you can't get into a site or a server, what does it take you to get back? Are you taking backups again from that disaster site and you have to actually reverse that or back them up somewhere else and recover to your original site? And again, how much outage are you causing, even if it's a planned migration back to your primary data center? These solutions, again, are cumbersome because of those first 2 points, and reverse replication just isn't automatically possible. The application impact, what does it cause in your environment to actually run these backups? Again, backup windows and network throughput and disk speed is a big factor in that, but also the CPUs and that extra workload it puts onto the servers as you're backing those up. If you're running agents inside the operating systems and they're heavily used servers day in and day out, you're really going to start impacting user experience based on how much impact this has and how often you have to back up your data in your applications. And then retention. Backup information is stored for a very, very long period of time, but usually that's one point in time over that period of time. So even one per week, you can only go back as granular. Once you get to a certain point of your backup archival rotation, you can only regain so many recovery points. You only have 1 point in time. Instead of one per day, now you only have one per week or one per month. So those are things to consider. What is a backup actually used for? What are the scenarios and outages you're planning for when you think about backup? And that'll help you lead down the path as to why that isn't a successful DR plan, because in DR, of course, the same considerations. What are you trying to plan against? It's not like that chart Keith showed in the beginning. There are so many factors that you don't account for as DR. You're thinking about those common insurance policy disasters. Well, all these other areas impacting your business every single day and cause days of outages, as you heard with the VA example, of course. That's horrific that someone could be down that long for what could be a simple IT problem that maybe didn't have a full DR plan tested out. So talking about replication technologies, infrastructure-based considerations, how do you get this done? How do you replicate your data? Array-based replication, again, that usually happens between a physical array replicating groups of storage called LUNs and replicating those to another array that's identical. So you do deploy that in your storage array and configure it and schedule it, and you're replicating the entire LUN. Anything that's on it doesn't really matter. It is designed initially for the physical workloads, just replicating data. Now, of course, in this heterogeneous data center infrastructure where we have virtual machines and physical machines, the array has no idea what's on there. It's just replicating. So it doesn't have intelligence as to when it should back up certain virtual machines versus physical data and how often and how to group those. So there's no visibility there, but it still has some need in the environments and some power there. Agent-based backup, much like, or agent-based replication, much like having an agent for backups, you could install an agent and replicate data. And you install that in every single operating system, only available for operating systems that that vendor has created supported agents for, which is hopefully extensive enough to cover your data center, but it could still fill some gaps. Agents, because they're agnostic to the hardware, virtual or physical, they're agnostic between virtual and physical machines, so you can install it anywhere. You're just installing inside the operating system. It has no idea that it's a virtual machine or a physical machine. It's just backing up whatever is going on inside that machine and inside the operating system. It does limit your scalability. Yeah, you can deploy thousands of agents, but it is very, very difficult to manage that, to manage the deployment, the upgrade process, and actually manage all your agents and what's going on with scheduling and everything else you need to worry about with agents, maintenance and support, and all the operations around that. So that's definitely a consideration as you scale is it manageable for your enterprise, or do you have to look at other solutions after a certain point? Scale not only in number of VMs, but also workloads on those VMs. How much is that agent taxed? How much is it taxing the operating system? Because that server itself needs more CPU or RAM. So just take that into consideration as you scale in multiple directions, horizontally or vertically. And then lastly, as Keith mentioned earlier, touched on hypervisor-based replication. That's looking at virtual environments and really tying into that hypervisor, that virtualization layer of abstraction to make it software defined. So replication isn't dependent on the hardware or the server itself. It's really looking at what's the I/O stream that's happening from that virtual machine down to the storage and capturing that data as it goes and sending it to another site. Sometimes that's continuous and it's sending every couple of seconds. Sometimes it's scheduled. It's 5 minutes, 15 minutes, an hour. So all of these can give you great advantages in RPO, of course, over backups of nightly, but sometimes you do array-based backups or array-based replication and agent-based replication once per day as well. It really depends on your needs and your throughput. So you have to consider all those areas when you're planning that out, but that's a different story for another day. Three technologies, and now let's look at what they can do and what it means for your business. The types of replication we talk about, usually when you see synchronous replication, that refers to array-based and physical. So when you're writing data to one side, it's going to confirm it and write it on the other side as well. So it's going to confirm both of those sides and know that the data is good on both sides before it continues writing the next piece of data that's come through. So both arrays are in sync. So that's great. It does limit distance between the two arrays. You can only go so far, and it does allow for, if something happens to array 1 or server on site 1, the other one can pick right up almost immediately and have zero data loss. Even if it takes a few minutes to bring that server back online, you could still have zero data loss from what site 1 saw. Again, that does limit distance, so you have to plan what are your outages that you're planning for with the solution. It does have its fit in certain areas, but you still might have to augment it with other solutions that can go longer distance in case you're worried about failures that affect your region or affect multiple buildings in your metro cluster or campus type environment. So definitely some considerations as to where it fits and why. The next point, what came out was asynchronous replication, meaning I don't need to confirm my writes on both sides. I can send it to both sides, but as soon as it writes to site 1, I'm going to send the next set of information to site 1 again. So information may not have written to site 2 yet, but it's on its way, and I'm still going to continue writing to site 1. Sometimes, or usually, that is actually scheduled, so maybe every hour I'm just going to send all the changes from site 1 to site 2. So that's where that RPO can fluctuate, depending on your workloads and your throughput. If I'm only sending data every 4 hours asynchronously, site 2 is up to 4 hours behind. So when that disaster strikes, what data are you sending every 4 hours and what servers does it impact? And how much data loss can you afford? So consider that for certain areas of applications or different tiers maybe, and you might need to have asynchronous at different schedules, just based on your business need and how much impact. If you were hit with something like a ransomware attack, you're only going to pay a ransom if you're worried about data loss. If you're not worried, 4 hours doesn't matter, and it's not that much cost to you to rebuild. It's not critical data that you can't recover or rebuild or recreate. Maybe 4 hours is okay. But other applications, maybe 5 minutes is actually too long. So you need to figure out what works for you. But the beautiful thing and the benefit of asynchronous replication is the distance. You can go worldwide in probably any solution out there. It just depends on how long that data will take to get there and how far apart you have to schedule those replications. But you can address the distance issue. So if you're worried about regional disasters or outages, now you can protect yourself against that as well. So as you can see, they do fit in together quite well. And then there's near synchronous. And that's not an official industry term around, it's really a type of asynchronous replication that is continuous. So it's not scheduled every 15 minutes or hour, or 4 hours or 12 hours. It's constantly going. You don't ever schedule it. It just keeps sending. As soon as it gets a couple of changes, some blocks come through that are different, it writes it, doesn't wait for the site 2 to write it. So it works asynchronously in that fashion where site 1 will continue to receive data and write, but it's constantly sending it block by block to the other side without waiting for that scheduled time to hit. And then we'll talk about snapshots versus continuous data replication. So we just sort of talked about that in the last slide, but if you think about point-in-time captures in this timeline on the bottom right. When am I taking my snapshots? Is my RPO? How far back can I look when that picture, that shot of my environment was taken and captured? So that's a point in time I can look back to recover to a known good state of everything involved in that replication schedule. So there are two types of snapshots in these environments. Storage level snapshots are exactly what I talked about when you're thinking array-based, and you're thinking asynchronous. It's sending that storage-based array copy every hour or every 4 hours. So you're scheduling it asynchronous, and you're just capturing it, all those changes that happened since the last snapshot, and sending only those changes at the next interval. So that's where that timeline comes in, where we're every 4 hours in this timeline here. Maybe your backup or your VM level snapshot is back 24 hours. And that leads us to virtual machine snapshots. That's on the hypervisor level, where your software, your third-party software, will trigger the hypervisor to take a snapshot of the virtual machine only. So it's not capturing a whole entire physical array on the storage, which could encompass 20 VMs and plus physical data. It's only capturing a single VM. So that does have its benefits, where you might only want a single VM and not sending all this data. But you schedule that as well. The only downfall to that, and why VM snapshots is showing close to a 24-hour RPO in this timeline, is in reference to best practices dictate against taking numerous snapshots throughout the day on heavily used virtual machines, because it can tax them or actually cause some outages. It can freeze up or blue screen a virtual machine. So you do have to take caution there and just understand when and how they should be used throughout the day. Continuous data protection, again, that's using change block tracking. That hypervisor-based replication is looking at everything happening in that I/O stream, everything going down from the virtual machine to the storage through that hypervisor layer, intercepting everything and just reading it, acknowledging what's changing, and taking a look at where that lives on the storage. So when it's time to send it to the other side, I can send it to the other side. Sometimes that's immediate in that near synchronous thought, where you can send every time the block changes, you track it and you send it. Sometimes it's scheduled asynchronously, so I watch those changes for the last hour and send them all from that storage. But that's really all change block tracking means, is just watching those points on the storage, and I don't need to make another copy typically and have that on storage. You look at the timeline, which kind of correlates to what Keith was showing earlier on the right, the different replication technologies and how that actually impacts you. So people love starting off with backups, and maybe you always use backups no matter what you do in the future, but it's a really, really cheap solution until you start thinking about a disaster. When you add in the RPOs and the RTOs and what that actually impacts your business, the most inexpensive technology that could be virtual machine snapshots or taking backups has the largest financial impact. And as we learned, you're all experiencing disasters all the time. It's just a matter of classifying them correctly as disasters and not just writing them off as we only got ransomware. Well, it impacted all of our systems and lost all of our data for a week, but you have to make sure you're classifying them correctly so that financial impact is better realized and you understand it, where it's coming from. Storage-based snapshots could be much more expensive than virtual machine level snapshots, but you're lowering your RPOs and RTOs, and you're driving more business uptime and less data outage, so that financial impact is quite a bit less. And then you can look at these at the bottom, continuous data replication, data protection technologies that can replicate continuously. You might only have 5, 10, 20 seconds of data loss, maybe even only a couple of minutes, and then a couple of minutes to recover. So the beautiful thing is recovering all of these technologies is much quicker than recovering from tape, if you've ever experienced that. So RTO is much lower. Total financial impact is minimized, and you're not worried about anything anymore. So it can fit in many different areas, not just mission critical, but obviously mission critical should be looked at first, but every single piece of your organization, no matter who it is, can benefit from maybe just continuous data protection, or maybe a subset of a combination of a couple of these for different types of scenarios. Snapshots versus CDP and what that means to your business and your infrastructure. You'll see the top line on the right, storing multiple snapshots. Of course, usually you have extra space on both sides for that storage array to keep those changes while it's still writing the main data, the original data down to disk. It still needs to maintain those changes in a buffer, we'll call it. and once that replication schedule happens, it has to send it to the other side. Well, if you only have one point in time to recover, if you replicate every hour on that timeline, and you only keep that one set of data, it doesn't take up much storage on the other side for those snapshots, but you can only go back to an hour ago. Well, if you have an outage and the data from an hour ago is also corrupt, if you had a virus or something, ransomware, and you want to go back to an hour and a half, you can't. You only kept one copy. So if you want to be able to go back every hour for 24 hours or for a week, you need to have enough storage space on both sides to keep all of those snapshots, all of those point in time that you can recover from. So that's where storage costs can get a lot more expensive, but again, you're minimizing that and referencing it towards your total business impact and the cost of downtime and saving face. Where continuous data protection can keep a journal, and you keep that on each side maybe, or you keep it on just the destination side, and it's not required to keep it everywhere. And it's only writing those changes that have happened every few seconds to the other side. So all those blocks that we're tracking and changing, you can write those in the journal. So it's almost like writing pages on a book, and you only have to go back a few words. If your outage happened, you can recover from 5 seconds ago. Maybe you only wrote 4 or 5 words in that book, so you're not losing chapters of your book from hours ago. In the journal, it takes up a lot less space on both sides because of that, and gives you a lot more flexibility and granularity and recoverability. It's very, very challenging, the second line here, to track how much usage your snapshots will take. So best practices dictate against keeping large numbers of snapshots and keeping snapshots for a long period of time. Both of those drive unpredictable behavior on your storage. You don't know what points in time your virtual machines will have a lot more data rate of change or drive a lot more growth in data. So those snapshots can grow and they can be long-lived, and the more of those you have and the larger they get in between all those snapshots that you have to read through to go back in time, the slower your storage becomes. The slower your storage becomes, the slower all the machines living on that storage become. So now even one machine could impact a whole group of servers, and that extrapolates to maybe all of your internal user base and your external customer base trying to gather or collect data or reports from those servers. So it's a huge impact there, where journals don't have that limitation. They're just separate disks that are just, again, writing these blocks, and they don't have to link and cut themselves off and rebuild and grow in the same capacity as a snapshot. So, and then array-based snapshot, there's the overhead on each side, like we said earlier, of keeping all those point in times over time, so you can have 20, 30, 40% of overhead. When you're spending $1 million on a storage array, it's really hard to think of $400,000 of that storage space is wasted for just snapshot overhead on both sides. So I'm buying 2 of them, $2 million worth, because they have to be identical, and I'm cutting 40% off the top. So that's really, really challenging when you look at journaling type of technology that might take 10% overhead only on one side, and it could be on cheaper storage as well. So a huge impact to the business, and definitely worth calculating as your total impact to business. So why automation and orchestration is important. You want to look at manual or scripted recovery versus automated and orchestrated solutions and what that does for you. But think about the process of recovering manually. It might not take a whole lot of time, but you have to consider if you're calculating that time for one server or one application. Now look at if a disaster impacts multiple servers or an entire site or multiple sites, what does that mean for recovery? If you can manually do it quickly, can you do it quickly yourself over 100 servers? Or do you need 100 people just like you to do it? Or do you have to start scripting these so you can kick it off and all of them can run in parallel? You have to figure out what that means to your business. Again, what type of outage are you planning for? Oftentimes you choose cost versus purchasing a separate solution, and that's where it gets tricky. People tend to not want to spend costs, especially moving from a backup mentality of this is so cheap and easy now, I don't want to add cost of replication technologies and orchestration technologies and all these other pieces, or spend the time scripting. But again, it's the impact of the business we need to start considering, and not the cost of the solution itself. Impact testing frequency due to increased complexity. So can you test? Some people don't ever test. Some people test once a year, maybe twice a year. But the reasons for that is because it's painful, and it usually causes downtime and causes outage. So now you're planning an outage Sure, you can have a maintenance window, but how much does that actually cost your business of no productivity and maybe no recurring revenue coming in or incoming sales while certain systems are down? So considering all of that, what that means for your business, limits frequency, but at least you have the peace of mind knowing it does work every 6 months or every year. And sometimes people do test once a year and it actually doesn't even completely work. So they never have complete faith that they can do it, and maybe they actually can't reverse failback as well and replicate back once they're failed over somewhere. So you're looking at RTOs, especially manual or having piecemeal scripts. RTOs are going from hours to days. The backup mentality, I used to be a backup admin for a while, and you look at 24-hour RPO and then 24 to 48 or 72-hour RTO. The recovery time to get servers up and running it just can't happen in today's 24/7 world. Automated and orchestrated recovery, if you look at solutions that can do all this for you, where you can pre-plan out with a few clicks of the button what these servers will do on recovery, if they need to change IP addresses or connect to certain networks or live in certain areas, or boot in certain orders, and after other servers have booted, so services come up correctly and applications actually start, and they're starting the correct order and they're running correctly, you don't need to spend time repairing anything, repairing data, repairing applications. So investing in this process ahead of time, pre-planning it, not only lets you have peace of mind when that stressful disaster event happens because you know it will work, but oftentimes you can do non-destructive testing any time of day, any time of year. You could test every single Monday morning if you wanted to, not worry about shutting down for the weekend and calling everybody in or being down for a week every quarter. If you can test anytime you want, non-destructively and automatically, you can see these tests improve your RTO to your business, prove those SLAs to your customers, and save peace of mind as well there. DR TCO considerations. We look at storage lock-in. So array-based solutions, I mentioned earlier, they do require the same storage on both sides, identical. Not even same vendor, but same model number, same firmware numbers. Everything has to be the same. It's very, very challenging. It reduces your ability to negotiate price. You know, it might be easy to negotiate price of one array, but when you have to start thinking about buying 3 or 4, and they have to be identical, you lose a little leverage there. But it also prevents you from trying new technologies and you know, making your business more resilient to change. I want to adopt this new array that's out that looks beautiful. It's tried and true in the industry for 5 or 10 years, and it's flash and it's fast and it's cheap, but I can't try it because I have to buy 4, and I can't afford to do that when I already have 4. So when you're locked into array-based solution, yes, they solve a need, but they have quite a few limitations. And when you look to upgrade one, you have to upgrade them all, or replication isn't going on again until everything's exact again. All the versions and everything has to be in sync. So you have some downtime of DR where you might not be protected, and that's the consideration you have to think about your strategies of upgrading, and that oftentimes delays a business from doing those upgrades or buying new things. And then hypervisor-based solutions operate at the virtual layer. They're not as tied to the physical infrastructure in many cases. Sometimes they have some tie-ins when they have to talk to those arrays. Sometimes they're tied into that hypervisor version where everything has to be exact, and others actually are agnostic to that as well. Even the virtualization layer, they're truly software defined, where they don't care what hypervisor is running underneath, what storage. It doesn't have to communicate in that fashion. It just communicates to the extensibility of those hypervisor platforms. So you have a lot more flexibility when you're thinking about trying a new array. It just appears as more storage, or trying a new type of cloud or type of hypervisor. You're not so worried about that. And you might be thinking, that doesn't really impact my business. We're tried and true and we have a set standard, but what's of course common, always has been common, but is increasingly more common these days, year over year, is mergers and acquisitions, and a lot of things changing. So change is really the only constant, not to sound cliche, but you don't know who you're going to acquire and what they're going to have for technologies. So think about the pain points you go through just to incorporate them into your current data center or merge technologies. It's extremely challenging. So you can use these solutions to actually help you with those processes. Recovery and automation, the array-based solutions, when you're trying to actually recover, because you're creating a copy of the data at a second site, that recovery LUN has everything on it. You're booting everything in there. All the virtual machines are recovered at the same time, all that physical data, whatever's on that. And you do have to run scripts to make those snapshotted LUNs available so they're visible and they can be accessed, because you don't want duplicate IDs across your environments. So there are a lot of precautions you have to take, automating some of it, maybe manual interventions. The more manual process that you incur here, as I mentioned earlier, the more you have to have all of your top-level experts involved as well. So it's a higher cost to you, and those resources are high in demand, not only for their day jobs, but when a disaster strikes, they're probably being pulled in multiple directions. So where do they start? If everybody needs them at the same time during a disaster, which one do they prioritize? If you can script it and automate it and have all this done ahead of time, they can be everywhere at once because they hit a few buttons, right? Hypervisor-based solutions are much easier and much more granular, because you can pinpoint certain virtual machines or applications, subsets of virtual machines that make up a full application across all of them, and recover them at the same time with a few clicks, have them come up automatically, and do all that reconfiguration as well of changing IP addresses and MACs. Sometimes the automation engine has all that built in, and you can call any external dependency that you need. The cost, the space versus cost, we looked at just that overhead. That's a huge consideration, looking at just licenses for acquiring new technologies sometimes is a deterring factor for people. They say, well, I already have a solution, or I'm not planning on buying one for another year or two, or this one's free for me. Look at the full factor of not only the cost of downtime, but the cost of the underlying infrastructure that you need to support that solution. If you require these huge SANs that are expensive, like I said earlier, that's something you need to consider. It might not impact you if it impacts the storage team and you're not in the storage team, it's someone else's budget. Well, it still impacts the business. So it needs to be looked at from the top down as far as overall good for the company and what it does for everybody, and also makes you have more availability, more uptime. And then the hypervisor-based solution, there are point-in-time recovery solutions where it's capturing these thousands and thousands of recovery points over time, all these little checkpoints, and this journal can grow and shrink with those blocks as they change. So if you have a busy period of time for a week, the journal can grow and grow and grow, but you know that journal will be committed over time, and when that server is no longer as busy, it can shrink back down to the usage that it actually means at that point in time. So you're not worried about growing a journal and then not using it, and it's just eating up empty space as well. So there's a much sets your mind at ease there when you're thinking about the solutions and what it costs, the infrastructure and the tax that it costs. Not only the cost of actually buying it and maintaining it, but also the performance hit that you get from either solution. Hypervisor-based, you don't see that same type of performance hit because of how the journal reacts versus storage arrays and all those snapshots piled on top of each other. All right, Keith, I'll pass this back over to you.
Okay, go on then. I actually thought you were going to do that one, Harry, but no worries. Give me 2 seconds.
Oh, I don't mind. Yeah, I can touch on this and then pass it over to you as well. So looking at the necessary elements of a DR plan, you can see on the screen here, important part here, part of our DR checklist as well, that you can find communication. Make sure not only have you communicated your plan ahead of time of what needs to happen, so when that stressful situation hits, people aren't scrambling because they have a plan that they've written down and they've tested, but also communicating with your end users and your customers. Make sure everybody knows where you are. Be ahead of them. You want to inform them, especially if you're in a social media world where Twitter might be a parent or one of these other platforms. Why don't you inform them before they inform you that there's an outage? That's not what you want to happen. So stay ahead of the curve. Have all your contacts. Everybody knows their responsibility. These RACI charts, the accountability, responsibility. Who do you inform, and who's consulted? But know who does what and when, and who they contact. Have all of your information ready, all your logins, any remote access you need. So if you lose a site and users can't get to that site to work, where do they work? What's your DR plan? That's part of business continuity as well. But how do they get into their information? How do users, even customers, get to the information? If you fail over to another site, they never physically got to your location, but they did over the internet, and now you have to redirect traffic somewhere else. So you need to be able to have all that information, not only for the end users, but also as step 4, initiating that recovery. If you have to initiate it remotely, can you get remote access? Does everything work? And can you do everything you need to do from there? But definitely document everything. Document even the successful, but even the failed DR tests are still a success if you document why they went wrong. So either you can have a process to fix it or fix it so it doesn't go wrong. There are sometimes you know it will fail and you know why. So at least in a DR scenario, you expect it to fail and you already have the solution, even if you can't mitigate that failure as it's coming on board online. So document every single step, even the failures, because they are successful DR tests. But so that comes to number 6, test your plan and enable your corporation, your organization to test it very, very often without impact to production, without having weeks of downtime or weekends of downtime. And then update your plan. If you made this plan for your business 6 or 7 years ago, even 3, 4 years ago, technology's changed so much that you can start revisiting this BCDR plan and pick what's right for your company. All right, so Keith, let's look at the future of disaster recovery. I'm going to pass it over to you.
Yeah, fantastic. Thanks for that, Harry. Right, so yes, as I was saying, we're going to just take a quick look into the future of disaster recovery to have a look at, some of the trends that are appearing in the industry, some of the new technologies, the different ways that people are starting to look at utilizing the cloud in particular for disaster recovery. The first one is DRaaS, or disaster recovery as a service. So the key part of the term here is as a service. So with DRaaS, what you're actually getting is really the skills and the expertise of a knowledgeable provider to assist you in actually managing any DR scenarios that do crop up. So rather than actually having to worry about initiating DR, managing that whole recovery process yourself, your provider handles that side of things for you. It enables you to return to operations as soon as possible. So rather than having to look after the daily maintenance and management and all the testing of your DR solution yourselves, for some businesses that's more ideal, and they would like to keep that in their own hands and have full control over it. Perhaps for smaller businesses in particular, the idea of leveraging someone else who has the resources and the expertise there to actually handle that for them. And it's something that DRaaS providers do every day. So they are very, very knowledgeable about getting the environments online quickly, helping you to avoid all the common mistakes that some people make. And they will also serve as additional resources that are focused not only on your data center recovery, but also on your overall IT strategy. And for a lot of organizations, their DRaaS provider originally, it has actually gone on to enable them to actually guide them further into the cloud and to be able to actually make further use of the resources that are available there as well. So this can be a really great way for businesses to both gain the protection that they need, but also to enable a little bit more of really the movement into the cloud and the transformation, which Harry will come on to in a moment as well. So it's, as I say, a great stepping stone, a great starting out point for many businesses, and particularly for those smaller and medium businesses as well. But this leads us into looking at the adoption as well for public and hybrid cloud, which I think Harry is going to talk to you about.
Yes, thank you. Basically, hybrid cloud is huge. If you don't have it now, you're looking at it already, and you're considering what impact that has to your business, and how do you get involved. And again, maybe it's because you're not ready to be involved, or you have hesitations, but you might encounter another company, organization through acquisitions or mergers that are involved in that aspect. So what is hybrid cloud? It's really connecting your data center to another data center that's not yours, disparate environments, and bridging that gap and making your data center extend, and that makes it hybrid. If it's public or hosted, so it's something that's not yours, or if it's private, it's yours, connecting some of these clouds together and using workloads across those is a hybrid cloud. Now, sometimes the hybrid cloud mentality, you can think of it even bigger as we want to make sure that's full duplex, as I'll say, as an old school term, I guess. Can I get information going both ways instead of just one way and not the other? Sometimes you can, sometimes you can't. But that's hybrid cloud, everything working together as it is one environment, but it truly isn't. You only own part of it, or maybe even none of it. What does hybrid cloud give you? That unpredictable bursting nature of disaster recovery. If a disaster strikes and you need to spin up resources somewhere, do you want to own those and have them on your own site, or do you want to have them in a cloud somewhere that you're connected to, so you can get that performance and those compute resources on demand and use that storage only when you need to, only in disastrous events or during tests, so you're only paying for what you use. The public cloud mentality is that swipe a credit card mentality. I swipe, I get machines. I start turning them on, I get charged for when they're on, I don't get charged for when they're off. So you remove that dependency of having your own second site when you're connecting to the public cloud or hosted cloud, managed clouds. So you don't have the costs of having identical hardware everywhere and identical storage arrays. If you look at these solutions that can accommodate, cross platforms and cross clouds, you don't, just that alone, never mind the fact we haven't talked about being locked into a lease. So if you want to move sites or get a different building or expand your building, you have a lot of limitations. And that's usually the last thing to move when you decide to move your office somewhere else is moving the actual data center. And it's not easy to do that. Even forklift moves and bare metal moves are expensive. But you also have to maintain and operate that environment and keep service plans on everything. So all kinds of upkeep is necessary. So that cost and the cost of what you need to do during a disaster event, you need to consider when you're looking at building your hybrid cloud. Maybe the cost per VM per hour on paper looks more expensive in a public cloud for some reason, but how much faster can they recover it because they do it every single day and you're only doing it once a year or twice a year? Understand all the aspects and how it impacts you when you're making these decisions. And you want to try to avoid those legacy solutions that are being barriers to your innovation. How much does it cost to differentiate between these and communicate between these different types of hypervisors or physical platforms and hardware platforms? Do you have extensibility through APIs? Do you have to script that and automate those with some other automation engine, or do you want someone else to do that for you? And get out of maintaining and get out of the data center business. If you're not a data center company, you're a software company or a retail company, why are you trying to be a data center company? Right? So I'm not trying to push public cloud or hybrid cloud, but that's what it all means to you. Sometimes one solution isn't right for everybody. So that's perfectly fine for you to go either way, but now we know why. Next slide, please. Okay, thank you. Digital transformation. What does this mean? On the left side, as we step up these stones from the bottom left of physical servers, we kind of talked through this already, but they have a lot of limitations. If you've done backups on physical servers and tried to recover it, that's where that RTO comes in of 2 to 3 days of recovery because it's painful. Maybe one server is 24 hours, but doing a whole data center can take days or weeks, and maybe a whole weekend or a whole week just for mission critical, and then tier 2 comes a week later or two weeks later. So your business is down for a long time. So that's where virtualization came in. Let's put that hypervisor in there and abstract that compute layer. So those virtual servers running on top of that are isolated from each other. They don't know about each other. They don't know they're on virtual hardware. It's all the same to them, but they also don't care what the hardware is underneath. They're not locked into that hardware. So recovery is very, very quick, makes them mobile and agile. You can move them to another piece of hardware, to another data center, and make those changes. Sometimes you just have to change networking or have much fewer dependencies, I guess. You're abstracting that compute layer, and then we move one more step to the right, the SDDC, software-defined data center. That terminology is talking about taking that concept of abstracting that compute layer from the virtualization era and applying it to other layers where physical hardware limits you. If you're limited in physical architecture with your networking and it's hard to span data centers or sites or different clouds, why don't you abstract the networking? There's software-defined networking, software-defined security and firewall, software-defined storage, and also, as you've seen, software-defined replication in the hypervisor. So abstracting yourself for as many pieces as possible, making your business more resilient to those changes. Anything that comes your way, you're ready because you built your environment to not care about the infrastructure, to not care about what's going on underneath or what physical location it's in. And any of those pieces, the more you can become software-defined, the more you're enabled to take advantage of any of these clouds, whether you want to be private, total public, 100%, or hybrid, any mixture of those, you have it ready to go. So it makes it really easy for you to adopt new technology, from the physical layer of servers to storage vendors to even hypervisors if you want to test different hypervisors out or move workloads to a different version that's cheaper or has better features for you. You can change in much smaller amount of time, maybe in minutes even, than what you can do today if you're bound by physical constraints. So it makes it really, really easy to not worry about your hardware investment that you've always had to make a line item of, and you can embrace that cloud. maybe go fully in the cloud and remove that physical dependency on your footprint of the hardware. Sometimes people actually migrate workloads to the cloud, but still keep an on-prem data center because they might use that now for DR and replicate back from the cloud down. And that's okay too. Maybe it works. Maybe you only have a few workloads locally again for certain reasons. Thank you, Keith.
Thank you, Harry. So just really the last piece that we want to talk to you about today is IT resilience. Now, this is something that is becoming really more and more talked about, particularly this year. You'll certainly hear a lot of businesses, a lot of the analysts bringing up this subject as well. And it's really something that has come about actually as kind of a long overdue evolution of disaster recovery solutions that brings them into line with today's modern virtualized and software-defined infrastructures, just as Harry's been talking about. By its very nature, the concept of IT resilience supports and enables that process of digital transformation by removing all of those physical dependencies that have been providing a barrier to businesses in the past, and now actually enabling that software-defined flexibility and data mobility that enterprise-level businesses are really, really looking for. Whether or not you want to have your IT strategy as all on premises, where you want to perhaps go down the hybrid cloud route and just test out DR, or maybe you're only looking at test dev, maybe you do want to go full on and actually start looking at running your production workloads in the cloud as well, and protecting those either back on premises or using a managed service provider perhaps as a disaster recovery site from the cloud as well. There are so many different options nowadays for how you can actually gear up and set up your infrastructure. The trouble with it is when you're really held up by legacy protection solutions that don't give you the flexibility you need to be able to move your data, move your applications around as and when you will. And as Harry has just covered, strategies change. It may well be that what you were planning to do yesterday isn't the same thing you're going to be planning on doing tomorrow. It's the nature of business to change, and successful businesses need to be able to adapt to that change as quickly as possible with minimal disruption, and obviously at the lowest possible cost for them as well. And there are solutions that are available. We obviously haven't really talked about Zerto during the course of this webinar. That's not why we're here today. But Zerto is one of those solutions that is there to help businesses enable IT resilience, so that, as you can see up on the top there, organizations can withstand any disaster, confidently embrace change, and just focus on business. So really that's going to be the end of our session for today. Love to thank you all for joining us. The content you've seen has actually been based on a DR101 ebook that we are just finishing up at the moment. We're going to be releasing that on Monday. So we will send a copy of that to everyone who registered for the webinar as well. And of course, if you'd like to join us next month, we do run these Master of Disaster sessions monthly. You can sign up for that at zerto.com/webinar. And that's actually going to be a session very, very different, looking at utilizing Zerto REST APIs as well. I'm talking about how you can leverage those to automate some of your disaster recovery processes. Of course, you can contact us for any more information, but in the meantime, if Harry hasn't got anything he'd like to add, we'd like to open the floor up to questions.
Yeah, thank you. I'm excited for that next webinar. It's digging in deep in the technical areas, not too deep, but definitely if you have more questions outside of this and you want to contact us, you can definitely reach us on Twitter as well. We did have a bunch of questions come in, so I've tried to answer them individually, but if you want, I'll do an open forum and read them off with the answers too.
I think if we got any unanswered questions left there, Harry, I'm just going in to check myself.
I think we've hit them all. I'm checking. So basically, I'll run through a couple of them anyway. So we covered the testing one and what's the limitation of testing, and that's a bigger talk. Then some of them were actually, again, we weren't keeping this webinar to be Zerto focused. It was more industry information and knowledge, but there actually were a bunch of Zerto questions, so we'll cover them anyway because people do want to know. How does the Zerto orchestration integrate with the Zerto solution? And the quick and easy answer there is it's all, so the Zerto solution, we do make software that does replication and recovery automation. It's actually all one product, one solution. So you get both all in one. You can automate the recovery or the failover or the testing of your environments. And you can also leverage it externally as well. If you have a third-party automation solution already that you leverage for a bunch of other pieces, maybe you're tying into other infrastructures that's not inside your virtual infrastructure, you can actually reverse it. You can call the other way and trigger calls to reach into the Zerto solution to make things happen, whether it's building out protection groups or failover testing or doing some reporting. So you can be very flexible in what your business needs and makes it really, really easy, but also robust if you need it. There was also a question actually around agent-based client replication. Does an agent-based client replication solution replicate the entire OS, or does it only replicate certain files and folders? I think that comes back to the mentality of a backup solution that you can check off sometimes the OS with certain agents and sometimes just the folders and files. Same thing holds true with agent-based replication. Usually they capture the whole thing. Sometimes they do have options where you have to select, do you want the OS or the information inside, and sometimes those don't happen at the same time. But usually it's all at once. You can capture the entire OS, but on recovery, it has the intelligence to say, do you want to recover the entire machine, or do you want to recover just files and folders? And it has visibility into that through their own solution. So there is some flexibility there, and typically you can just capture everything at once. Will we share the presentation? Like Keith said, yes, we're going to send this out, the recorded webinar, and also, yeah, look forward to that ebook coming out next week, because it has a ton of this data and a little bit more as well. And there was a question around, again, Zerto's solution, which is called Zerto Virtual Replication. Are you guys reselling a cloud service, or does Zerto own the cloud hardware? I know that oftentimes, not often, but sometimes come across with confusion. Zerto is a software company providing this software that promotes IT resilience that was originally based on disaster recovery, but can cover all kinds of scenarios. No, we don't host it in the cloud. We don't sell it. We have partner resellers and we have partner cloud providers. Resellers you can buy it perpetually and own it yourself and manage it and run it, or you can subscribe to a service through a cloud provider or a public cloud where you pay as you go and just get DR as a service or disaster recovery to the cloud in that fashion. So you go through our partners network of resellers or cloud providers. I think that is it. I don't see any other questions unless you see some, Keith, that you want to cover.
No, I think you've got them all there, Harry. That's great.
Awesome. Well, thank you, everybody, for coming, and I'll let you close it out, Keith, if you're all set.
Yeah, no, I think you've summed it up very nicely. As I said, thank you very much all for coming. Please do sign up for next month's webinar if you're interested. As we say, we hope you've really enjoyed the content today, and we'll make sure that the ebook with all the extra juicy details comes out to you next week. Thank you very much for your time. Take care.